Hello guys, welcome back to the channel for another DataBricks video. In this video we are going to see some of the PySpark and Spark-SQL basics according to the DataBricks courses. It will help you if you are preparing for the first DataBricks certification, as similar examples are in the courses they provide. This is mostly about how to read data from files, data lakes and databases. I try to keep it as simple as possible, like always, so let's dive into the code. We will start by querying a single file. For example, we can query a CSV file or a JSON file directly. How can we do that? By using spark.read.format. We specify the format here, and the option if we want a header, if we have a header in our CSV. So you just type header is true, and .load, and you specify the file path. So if you want to upload a CSV on your DBFS like I did here, what you have to do, the first thing you have to do is click on your account here, and then click on admin settings, and then click on advanced, scroll down, and where you see DBFS file browser, enable that, because by default it's disabled, right? So let's go back in our script and run the first command. So if you run this command here and then you type dataframe.display, it will give you back the results. As you can see, it's a very small data set, right? Nothing fancy. And you can do the same thing with a JSON. For example, here we have also a JSON, and if it gives you, if it's nested, or if it gives you a strange error like this one, for example, that the queries from row JSON files are disallowed. So just use option multiline equals true, and then .load and specify the JSON path. Again, it's in our file store. Let's run this command here, and you will see the results. Now, how can you actually browse this this file here? You click on the catalog, and after you have already enabled DBFS, so you can browse the DBFS, shared uploads, and you upload here, click on upload button or create folder, whatever you want, and this is how you upload files on DBFS. Let's go back to our script again, and here we are. Now, let's query a directory from a data lake. So instead of using our DBFS here in DataBricks, we can query a CSV file or data that exists in our data lake, in our storage account. Now, if I go to my storage account, let's go here, storage account, containers. I have files here in this container, input container, right, in this storage account. Now, by default, you don't have access to the data lake. So what you have to do is actually allow DataBricks to query our data lake. You can do that by using an account key that you can find here. Sorry, let's go back to our container, access keys, and just copy that key, paste it here where it says as an option the account key, and then so you set this Spark configuration here in order for the DataBricks, your DataBricks environment, to access the data lake. Of course, there are multiple ways to do that. You can use account key or a service principal. Usually this is the case. You store your credentials, the service principal credentials, in your key vault. From here, from DataBricks, you access the key vault, you get the password of the service principal, and using this service principal, you actually access the data lake. But here, because I want to keep things simple, just use an access key, an account key, and then you can query the data straight from the data lake. I got an error, and I think it's because I forgot to run this command, of course, you have to run the command first and then run read the data from the data lake. So you can see now again, spark.read.format option header, and you just specify a different path that points to the storage account, abfss // int, the input container, and the storage account, etc., etc. So you can see the data here, right? And you can do the same thing using SQL, right? Select everything, select star from CSV. Let's run this again. However, here, what's the issue here? If you use straight SQL, you cannot specify like that the header is, header is true, like we did up here. So usually what you do is create a view that specifies that the header, the first line is the header, and this is how you can query using the data using SQL. And here, as you can see, have the same example: create table, if not exist, test CSV, and you specify, of course, the fields here using CSV, and here you pass the options, header true, delimiter, comma, and you specify the DBFS location, right? So, or your account storage account location. So we created a test CSV table in our DBFS, in our Hive metastore actually, and you can select and perform whatever query you want to perform on this table. Now, how can you find this test CSV table? You click on the catalog, Hive metastore. I think I have it in this schema, apostolo schema, and test CSV. You click that, you can see the columns, and you can see also sample data, right? And details here, of course, etc., etc. That's an external table, not a managed one. Let's go back to our script. And let's scroll down. Moving on, we can create a view, create or replace view, the view name, and as select star from DBFS or our CSV file. So if you run this one, you can create a view, and you can create the view as you query the table. Nothing special about that. And you can see this view on the catalog again on the same place that we created the table. Now, of course, you can create a temporary view, which is very, very useful, and it comes in handy when you just want to play around with data. So you create a temporary view, and you select your file, and then you can play around with the data in this view. However, temporary views exist only for the current Spark session. On DataBricks, this means that they are isolated to the current notebook, job, or DB-SQL query, right? So once you terminate the cluster and you start it again, then you won't be able to query this temporary view. So that's perfect. You don't want to actually take space, and you use temporary views just to play around with the data, perform calculations, and that kind of stuff. Then we have the common table expressions, right? So the with clause, the infamous with clause here, with whatever name you want to provide as, and then open brackets, you select the data you want, and then you can select from this common table expression. I'm sure most of you are pretty familiar with clauses. They come in handy when you have, when you write big complex queries. I don't think you can do it without using with clauses, or at least nest inner queries and nested queries. So if you use, of course, if you try to actually select from this common table expression outside of the current query, you can't do that. It's only for the current query you are creating, you are using the with clause, right? Then we have extracting data from SQL databases. Let's say we want to query data straight from our database. For my example, I used an Azure SQL database because this is what you usually use when you work with Azure and DataBricks. But you can query MySQL and other databases. You just provide the URL, the table, the user, and the password. And you say create table using JDBC, and you pass all these options. One important thing to note here is you need to use a single node cluster. If you are running on a cluster with multiple workers, the client running in the executors will not be able to connect to the driver. So that's an important note. And a second important note is this statement here, this syntax here, actually creates a Spark table that points to the table that you have in the actual database. So it's a reference to the table that you have in the database. That means you can query the data. Yeah, of course, you can read the data, select from the data, whatever, but you cannot, it does not support updates and deletes, right? So you can only essentially select from the data, view the data, and you create a Spark table. Now, let's say you want to read the data, right? So how can you do that? Using PySpark, you can do that by using spark.read. You pass the JDBC driver. I think after cluster version 11, you don't have to download and install the JDBC driver. It's already built in here using SQL Server for the Microsoft database, of course, and then you specify the host, the port, the username, the password, the database, and the table, right? And you .load, you type .load, and then display the data. So if we run this command, it should work here, and we should be able, to see data here. Now, let's go back to Azure portal and check our database. So let's actually allow our IP address, otherwise we won't be able to see the data. Let's go back, query editor, provide the password. I don't even remember the password here, and click on OK. And here we have our tables. Now let's say simple table with simple data, right? DBO schema and persons as a table name, and that's what we specify here. A database in the table with the schema. Okay, so if we try now, that's exactly the same thing using, this is how we actually read data from the database, and this is how we can create a table. So let's say we can create a schema. If not exists, let's say test 1, 2, 3, right? And use test 1, 2, 3. And drop table if exists, pull test 1, 2, 3, and create table using SQL Server. And now here in the options, actually we point to that table using, providing all the information. So if we run this query here, right now, if we go into our Hive metastore, we created a new schema, test 1, 2, 3, right? And here, this table here with the sample data that you can see here, right? So we created a Spark table, but this is just a reference to the SQL database. And I will prove that to you now. Let's go back to our script. And let's run the next query. That was this one here. For example, let's update the table, right? And change the city. For person ID, we equals 1. If we run this, it says update table is not supported temporarily, right? If you again try to delete, you will get the following error: the feature is not supported table, Spark catalog, test, etc., does not support delete. So you cannot, it doesn't support delete or updates. You can just view the data. But you can select from the data, create CTEs, and do all your testing and transformations here. Now, how can you inspect missing data that we loaded from the table, right? What's our table? Let's see the data. You can see we have person ID, last name, first name, address, city, right? That's very dummy data, of course. So let's select and check if the city is null. Check the count. So city has to be null. We have one record. So when we check for missing data, we should get one record. Yep, we get one record. You can use count if, or you can use count star, where city is null, of course, very typical. And if you're using Python, you can do the same thing. So you need to use the call function, Spark function. So you read the table. That's the new table. So this is how you read a Hive Metastore table here, a Spark table, spark.read.table, not load.table, and you specify the table name, and you create a data frame, and then you filter where city is null, and then you dot count, and you will get the count. One, right? Perfect. Let's say we want to dedupe the data. Now, one typical way to do that is use group by, right? And group by person ID, for example, usually the ID, and select from the data. Okay, so this is that's how you dedupe the data, because if I recall, we have a person, we have three people actually with the same ID, right? My name, Anna, and Helen, so with the same ID. How can we dedupe the data? We group by person ID, and we dedupe the data. Now, usually, now here we got Anna, right? But usually, how you do that, how you dedupe the data, how you select, because now with here, for example, we have three records, right, with the same ID. But how do you know how, let's say you want to choose Apo or Anna or Helen, so you want a specific record usually. So how can you dedupe the data? How can you do that actually? Not dedupe the data in a way, but actually select the record that you want when there are multiple people with the same ID. And this is using analytical functions like row number over partition by person ID. And you have the RN here, right? So the row number. And for example, you order by last name. So last name, if you order by last name descending, you will get Helen. So that would be the record that you are going to select from all these three people. You are going to select this record with last name Helen, because that's how we used our analytical function, row number over partition by person ID, order by last name descending. And then in outer query, select everything from the inner query, and where row number equals 1. So let's test that again, and we will get Helen here. Now, if you want to get Anna, you will get, you need to change that to ascending order, and you will get Anna. That's very simple, but that's how you select the right records, the records you want, right? You can do the same thing using PySpark. Again, import the max function from the SQL functions, and that would be apply the where condition where city is not null, group by person ID, and aggregate and select the max for last name, right? And this is how you can actually group by the data. The last example is about validating the data sets if there are duplicates. So we select from the duplicated data that we used here. As you can see, a temporary view of the duplicated data, right? So if you select from that, select from this view group by person ID, and then you perform a max row count. And if it's less and equal to 1, that means there are no duplicate IDs. You will get true. So if you run this, that would be equal to true. That means we don't have duplicates. And using the same thing, using PySpark, you have to import the count function, and that's the data frame, group by person ID, aggregate, you perform the count here, star, the row count, and then you select if the row count is less than equal to 1, there are no duplicate records, and run, that's true, and yep, we verified that we don't have duplicated records. And this is how it's done. This is it for today, guys. Entry-level examples in PySpark and Spark-SQL to query files and databases and the data lake. Similar to what you would see on DataBricks courses. I'm going to upload the notebook on GitHub if you want to take a look and play around with this code. And hopefully you enjoyed the video. Please click the like button, subscribe to the channel, leave a comment, and I will see you in the next one. Thank you.